Hey, hello, and welcome to another episode of the Indoor Environment Show. I'm Bob Krell, founder and publisher of Healthy Indoors magazine. And as always, I'm joined by my co host, Mr. Don Weeks, who is the president of the Indoor Environmental Quality Global Alliance. Don's coming live from Ottawa, Ontario, Canada, and I'm actually coming from a undisclosed location in Maryland, in the United States.
Well, welcome, Bob.
What's happening?
There, well, we're getting through the winter. You know, the last day of January, so it's cold here, though. Let me tell you, about minus 13 Celsius. So, but we're
Wow.
making it through.
Well, I can honestly tell you down in Maryland, in the Washington, D.C. area, it was 60 degrees yesterday.
Ah, yeah, nice.
It,
Thank you.
yeah, there's no climate change going on to
Yeah,
speak of.
yeah.
So I'm super excited about today's
Mhm.
show. It's a topic that it's near and dear to me in my consulting career, dealing with bioaerosol issues, and we're bringing one of the all-time experts in the industry on today. So I'll let you do the introduction.
Yes, thank you. And a good friend of mine as well, Dr. David Miller, who is really, in many ways, doesn't need an introduction, but I'll do a brief one. In 2000, Dr. Miller became professor and NSERC research chair in fungal toxins and allergens at Carleton University. And in 2020, he was appointed by Carleton University as distinguished research professor. So today's topic is going to be on rethinking bioaerosols, and today's webcast is sponsored by AIHA, the American Industrial Hygiene Association. Back to you, Bob.
Yeah, I did want to point out that this production, the Indoor Environment Show, is a co-production of the ISIAC International Society of Indoor Air Quality and Climate, and IEQGA, the Indoor Environmental Quality Global Alliance, and is produced by Healthy Indoors. So anyway, without further ado, let's bring in our guest. Hi, David.
Hi there.
How are you, David?
I'm surprisingly well.
Well, that's good. I'm glad to hear that. One of the things that I'm always interested in, and I use this question a lot with the individuals that we have coming on, is basically considering your background, education, mainly in biology, but also in other areas as well. How did you become interested in public health, industrial hygiene, and indoor air quality?
Yeah, so yeah, my expertise is was at least started on the business of understanding the chemistry, toxicology, and ecological environmental health as impact of fungal metabolites, secondary metabolites. So most people know a really famous fungal secondary metabolite, penicillin, which is a good metabolite, of course. Um, but I was hired in the midst of a crisis at Agriculture Canada in Ottawa around a toxin that is pervasive in wheat in the northern-ish part of the U.S., the Great Lakes areas near the border, southern Ontario, but also globally. A mycotoxin called deoxynivalenol. And what had happened was that after ignoring it after its discovery in the mid 1970s, there was basically a catastrophic failure of the wheat crop all around the Great Lakes. And I often say, if you don't think that makes people excited, I don't know what you think it would take. And it took a lot of money um, spent as fast as possible to come to some understanding of what a regulatory level would have to be. And there's a suite of other fungal toxins. Uh, I'll just take a minute. It's invisible to us in North America because we have so much excess capacity. But every year in the United States, it costs between 300 million and 1.5 billion dollars of direct loss to farmers because of the presence of these toxins in crops. But that then flagged my expertise in the government as somebody who understood about fungi and what they made, their chemicals and so on. that might be relevant to human health. And so, as I always say, I was voluntold by my employer to start the work on housing and health, as well as failures in big buildings that were going on all over North America back in a day when it was considered okay to put fibrous insulation inside ducts.
Oh, it still is here in the United States, David.
Well, you're not allowed to do new ones. But imagine that's right near the old-fashioned humidifiers, which were, a recipe for fungal heaven. And so there was a lot of effort to and a lot of resources to really try to come to grips with that as a strategy forward. And then I guess to finish this, I would say that armed with that investment, decisions were made to begin a series of very large and expensive studies on the population health impact and the mechanisms of fungi particularly, but never losing sight of the fact that in housing particularly, there's endotoxin, there's allergens of various kinds, and trying to make sure that everything is being measured so that what's called the attributable risk, okay, how much can we blame on fungi, or what else do we need to be measuring, to properly understand the situation in a building. And the last piece that I spent quite a bit of time and a mountain of money on was that when the first big studies on mold and dampness and health were published in 1989 and by Harvard and by Health Canada in 1990, they said that if you lived in a moldy house with a threshold, you were more likely to be allergic to everything. And you were more likely also to have increased rates of viruses. And the immediate recognition, or the immediate response from the medical, especially community, was bullshit. And the reason is that there was no understanding of why that could occur. It made no sense. So I did then go on to spend a couple of decades actually figure out precisely why it happens, so that the original findings, and of course many since then, are actually real, not artifacts of epidemiology.
So that was initially in your period of time working with Agriculture Canada from 82 to 88. You were the head of the Fusarium mycotoxin program. Can you kind of give us an idea what was the intent of that research program and what was your role as its head?
Yeah, well, as I said, it's invisible, but if you guys ate a muffin or cereal today,
Yeah.
you have the metabolite of the toxin that's most common in wheat in your pee. It's like these natural poisons. We can't tell God, as I say, to stop making them. So we have to live with them. It's not like these bad chemicals made by some company or other will just tell them stop making them. It just doesn't work like that. And as I said, the challenge was that you have two choices: starve everybody, or figure out exactly what would be a tolerable level. And to do that in a compound that's a high human exposure compound, not just in North America, but very much so. It's worse in Europe, China, other parts of Latin America, for example. You have to be very careful to choose wisely. Because, as I said, no action should be taken to increase the price of food unnecessarily, especially of something like wheat or corn. It also occurs in corn. And so no expense was spared to actually really understand what would be tolerable. So my job was firstly to figure out how to make dump trucks of the family of chemicals so that we could do long-term toxicology studies to really understand what the mechanisms were. And there was colleagues at the Michigan State especially were also very important for that. And so that we could settle on a number. And of the 5 agriculturally important mycotoxins, which I tell often my sanctimonious European colleagues, there's 5 that are important. the investments to properly understand that all have come from the United States or Canada. The one for the deoxynivalenol, the toxin that I was instructed to work on, and it was a great privileged opportunity. The international tolerable daily intake is set with the Canadian study for two of them. The studies, three of them, the Americans they're American studies, two of which done by the FDA. And one of them is, it takes two studies, one of which is Canadian, one of which is from the FDA. So it's invisible to us in North America, but our food systems globally are challenged. And just one more comment on this, aflatoxin is the most powerful human carcinogen known to man by 100,000 times, to which a lot of people are exposed. It causes about a third of the liver cancer on the planet. No one in the United States or Canada now, but in the 60s, 70s, it wasn't discovered until 1962. A little bit into the 80s, people in the southeast of the US did have elevated liver cancer. The last really giant problem in the United States was in 2012. It screwed up about $1.5 billion worth of corn. And that was invisible, except that the price of milled corn and sugar went up 10% all over the world because the US is such an important corn producer. So for us, it's invisible, but in Africa, parts of East Asia, parts of Latin America, these things are killers. So my job was to figure out how to make lots and lots of these chemicals so that we could test them properly. And to do that, it involved discovery. So there were all kinds of expert chemists, toxicologists, others, people who dealt with the plant side, including me, to properly understand that, and we do. So it was, and you would already gather that for something of that consequence, the United States and Canada, we're not going to skimp. Whatever we need to do to properly protect our food system without increasing the price of food unnecessarily. So that was sort of began and still is a theme of my research life.
So my question would be, that is extremely important work, obviously, as you described it. How did you get involved more, what I would call the AIHA and ACGIH and other organizations that were more oriented towards airborne contamination, particularly in workplaces? When did you start noticing that particular field as being an area that you wanted to add some expertise to?
Well, again, remember I worked for the Crown, and after I came to Carleton, I was a science advisor to Health Canada. There were these three things going on. There was problems in residential housing, and we didn't understand why it was happening. So you wouldn't want to make an intervention unless you really did know. And because mold is inevitable in every building, there's always some mold. It's the same question that I raised with you about the toxins in grain. How much is okay? Because currently, the best data are that around 15% of homes in the United States and Canada have enough mold damage that affects population health. Whether it'll affect you or not is a different question, but on a population level, those are the data today. It's not gone away because we can't make it go away. We have to learn to manage it, right? So making it perfect, like making grain completely free of the natural toxins, that's not happening. And neither is making a mistake about that. So really comprehensively measuring things. So how the big buildings came about, as I alluded to earlier, it was in a time after the first energy crisis, where not in Canada, but Don would probably know or remember, there were lineups for gasoline in the United States. My God, because there was embargoes on oil, and the price of fuel when I was in university was more than it is today in constant dollars. So it was real trouble for a student, right? But we tightened buildings up. We did a bunch of things, and plus we were living with a legacy of bad designs, like humidifiers that were basically vats of water that got dirty. So of course bad things would happen. High prevalence of perimeter induction units with insulation in the drip pan. High prevalence of HVAC systems in big buildings that had fibrous insulation rather too close to the humidifier, or at least the HVAC unit where the AC was, if you like. In other words, prone to getting wet. And there was a harvest of that, not everywhere in North America, I would submit, but certainly in buildings owned by the Canadian government. And so there was a lot of pressure to try to rapidly come to terms with what needed to be done. And so one of the things we did was we established provisional guidelines on how to manage that, and that was initially in 1988. And I got involved with AIHA because, in part because to do that, like we could do the tests in the government labs, but that's outrageously expensive and not a good use of taxpayers' dollars. So our public works department would be like the analogy for the federal government in the United States. Set in motion a process to accredit private laboratories for basically to provide services for the government, not for the world, but of course, if the government is buying from a lab, it probably encourages other private people to buy there. And that's actually what caused me to be invited to my first AIHA meeting in 1991. But then I could see the opportunity, which is skilled, dedicated professionals who take what they do seriously, quite educated, really value the role that they play, whether they say it or not, in public health. And as both of you know, as all of you probably listening, is part of the process that creates cognizant authority standards, guidance documents. And that of course can be done so much faster than in government, and then are more universally used if you deal with the professional communities, actually a little bit with ACGIH, but mostly with AIHA.
So I'm going to jump in, John. Don, I'm going to jump in. So we have some questions from the audience, and I wanted to point out that if you're watching the show live, you're able to comment by going to the live broadcast at the Healthy Indoors online community, which is at global.healthyindoors.com. That's the URL, and you look for the Indoor Environment Show and you can get it. Our first question that we have in here is the first one's actually a comment from Jack Springston. Please address the fact that fungi growing on building materials do not produce the 5 agriculturally important mycotoxins, and why. And a follow-up to that, which is actually more of a question for him. I think that's the one we'll go with, David, is can fungi growing on building materials such as drywall produce any of the agriculturally important mycotoxins?
Yeah, so Jack knows the answer to that.
Of course.
And the answer is no, 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 I can't. And I mentioned that I had spent about 15, 20 years of my life trying to understand why the health effects of fungi are seen, the 2 big population health effects I alluded to, making you more likely allergic to everything, increasing your risk of upper respiratory disease. And it's a lamentable fact that uniquely in the United States, there's a whole community of people who suggest that the ones that occur in crops, the agriculturally important mycotoxins, which are dangerous, occur in buildings, which is simply not true. The fungi don't occur. They don't like to grow on building materials. They like to grow on crops, which are rather different than paper-faced gypsum wallboard with water in it, right? Instead, what grows, as probably most listening to this, is a suite of fungi. There's pretty exhaustive tables of this in the Green Book. So one of the things, because one of the allegations was it was these mycotoxins that are causing part of the non-specific health effects. So I more than anyone spent nearly 20 years of my research life looking at, well, what do they make? What do they do in relevant animal models? Would that connect to the health impacts on humans? And the answer was, for the low molecular weight compounds, essentially the answer is no. But none of them, the chemistry of those, which are in many papers and review articles that I've written, co-authored, is completely different, which means their behavior is different. And we know what they do if you breathe them at relevant doses. And no, you can't measure them in, lab X, wherever, because there's only 2 people in the world who have standards, and I'm one of them. And I won't give them to you. And the second piece of the answer is that there is some chemistry in the spores of fungi that live in buildings that turns out to matter, but they're not mycotoxins.
So I have to follow up on this, because this is a major statement here, because obviously the entire industry, at least in the United States, and I would say probably globally, is inundated with claims about mycotoxins, trichothecene, other mycotoxins being generated by these environmental fungi, right, in the indoor environment, and causing many adverse health outcomes. So I just want to clarify what you're saying is that's really not the case.
And it's not me. I mean, that's the position of the National Academy of Sciences, position of Health Canada, the position of the WHO. It's the position of the American Academy of Allergy, Asthma, and Immunology. This is where everybody agrees. It's the position of the European Commission. It's not. There's no dissension about that, except in the United States.
Yeah.
It's not rare in science. You've witnessed it in a way with COVID, for there to be outliers of people who offer hypotheses, and in the world I live in, know what they read as opposed to know, to offer suggestions. And I think it's also, which has causes trouble sometime for Canada, basically the idea of selling services to measure mycotoxins in urine, something that literally only, frankly, there's only one lab in the US that can do that properly, and that's the CDC. There's one lab in Canada, which is in Agriculture Canada, and there's 2 labs in Europe. So it's just not something that grows on trees, because of the expertise, the standards, and the skill sets and instrumentation. That's not to say that there isn't a biochemical reason for the health effects that we see, but it's not related based on not just the evidence, but the cognizant authority opinions to the so-called what I call low molecular weight, because mycotoxin, with all respect, has a meaning. And Don's first question opened that up. It means compounds that occur on crops mainly, but also like hay or something, that are known to cause health impacts in human or animal health. That's the definition since 1958. It's settled opinion. And compounds that random out of the air compounds, we don't know until somebody actually measures them. But I emphasize that in me and my collaborators have looked at the major metabolites of all of the most important fungi that occur on damp building materials. Pick the most important of them in terms of frequency of your life. The amounts that occur on damp building materials are so small that you need a machine that costs like $500,000-$600,000 to measure them. There's not a lot of them. Nonetheless, they do get into fragments that you might breathe. And when you do all that, there are some effects, but they're not important compared to the other major, basically, center of opinion now. And since I've alluded to it, it's a polysaccharide that's present essentially in what we call mold fungi, called beta-1,3-D-glucan. That's important. ACGH says, or Quad AI says that. The literature says that. The WHO says that. That's where the evidence lies. It's not nothing, but it's not a mycotoxin.
So obviously, I mean, this is, the accepted science, that you're presenting here, really goes in the face of a lot of anecdotal stuff that ends up on the internet. And in the United States, there's a heavy market of people pushing the mycotoxin deal. So as far as the exposure to the agricultural mycotoxins, are they predominantly ingestion, or there's also an inhalation possibility, right?
Well,
Grain silos.
Yes, but because, so I brought up aflatoxin with a very, very, very potent carcinogen. You got that? Does some other things, bad things too, and kills pretty large numbers of children and dogs, not uncommonly, even in the United States, from dodgy pet food companies. In fact, I think it was last big warning from the FDA, because the FDA regulates pet food for some reason, was in 2016, and dogs die. It just happens. But the bulk of the exposure is from eating for the open citizenry. But because aflatoxin was common and is still not uncommon in some seasons in some parts of the U.S., it has to be managed. And of course, from the forever until the modern grain dust standards were established, it was common for grain dust for people working in grain handling facilities to have measurable inhalation exposures. In fact, NIOSH had a fairly large program on that, which is another reason why people from agriculture, like me and like initially from NIOSH, became involved in the built environment world, because we'd had this expertise worrying about health of workers. So yes, in the olden days, workers in mills that handled peanuts, corn in bad years, they did have an excess of liver cancer. And so NIOSH went right at that. But even if we take the Stachybotrys, which is fairly actually an uncommon problem compared to all the other fungi, a really good researcher at the Hunter College in New York, who is an expert on studying the impact of different factors on mouse behavior, has published now 2 papers where she believed that it was Stachybotrys toxins that were causing the problems. But after some discussion with me and others, she's a very good scientist. She did 2 experiments. A recent paper has just come out, where she took spore stuff from Stachybotrys, extracted it to remove the toxin, but not the structural components like beta-glucan, and then exposed mice to different learning tests with the two conditions, the material with the toxins and the materials where the low molecular weight compounds have been measured. And in fact, almost all the health effect on the mice was from the extracted. In other words, the material without any toxin, low molecular weight compound at all.
Wow, those are interesting studies. We'd appreciate probably if you could give us a link, after the show, and I'm sure many people would like to see that information.
Yeah, it's cited in the long pending ACJH, where the issue of metabolites, chemical and volatile and others is explored in exhaustive detail, and I'm not surprised, because it turns out. So why is glucan important? Since you're asking me these heavily scientific questions, and why isn't it a problem? Because we're breathing bazillions of spores in outdoor air. So it turns out, and mushrooms. So it turns out that the chemical form of glucan that's common in mold, that basically the molds that we're familiar with in moldy buildings, is different. They're all glucans, mushroom glucans, the form of glucans in the fungi that are common in outdoor air, which are basically fungi that live on the surfaces of leaves. The chemical form is different. And it turns out that it's kind of like an appendix. We have a receptor in our lung that we inherited from some creature 400 million years ago. It's called the dectin receptor, or it's another way to say the glucan receptor. So it turns out that when we breathe spores or mushroom spores from outdoor air, dectin receptor doesn't turn on. It turns out, though, that if we breathe the spores of the sorts of fungi that occur in indoor air, it turns on big time. It's exquisitely sensitive to it. And that receptor is part of a machinery that mammals have, to help to warn us about something. So it's sort of like a warning molecule. But unfortunately, kind of like the appendix, today it's a big nuisance to turn it on. So it causes inflammation in your lung and sets in motion cascades that are not favorable. The second thing, always remember when you breathe the fungal spore is its allergen. A lot of allergens, including but fungal allergens are among the best studied now, are often enzymes. So they're capable of chewing things up in your lung, not in that kind of graphic way, not like Pac-Man or something, but they're capable of causing damage in your lungs. So for those who do occupational health management, you may know that cetirizine, which is an enzyme used or was used anyway, in dish detergents or in laundry detergents to degrade protein stains, it's a potent allergen, but it's an enzyme. So a lot of the fungal enzymes, including the ones that I've studied from fungi that occur in building environments, which no one had studied before, they are allergic. So you are entirely capable of getting allergic to the most common fungi in buildings. And we don't have commercial tests for those, but we know that for sure, because the way they were discovered was with human sera collected in a big lab in the United States. And if I compare that, just since I'm on allergens, penicillin, the penicillin producing fungus is actually the most common species of penicillium on damp building materials in the United States and Canada. And it makes penicillin and related compounds, among some other metabolites. About 40% of people that are genetically prone to be allergic in the suite of sera that I got from this giant lab in the United States clinical testing lab, are allergic to the most common penicillium, whereas for Stachybotrys, it was somewhat less than 10%. And for those of you that are practitioners, I'm sure you're not shocked. But always bear in mind that fungi produce allergens. All of them do. We don't know the names of them all, but we know the ones for the most common building materials. And it turns out that the form of glucan that I mentioned, it just is different for most of the common building material molds compared to the ones that occur in outdoor air. So that's why it's special.
So we titled this particular webcast "Rethinking Bioaerosols," and I wondered, in your view, what has changed in the nature of occupational environments with regards to fungal bioaerosols?
Well, it's gotten a lot better.
Okay.
A top level answer. I mean, as I often say that in 1988, when I published my first paper on this topic, ACGIH's advice was that mold in a building was ugly, but it wasn't much of a health hazard. And I always say, who would say that today? AIHA particularly has made a huge effort, at least since 2002, to produce good quality consumer materials. Engineers are with the program in terms of figuring out proper designs and So we've really improved a lot reduce the risk of mold accumulating in buildings, but also improved our strategies to deal with it for floods, the Green Book, and also for good consumer information. And similarly, Health Canada has pretty good consumer information. So I've alluded to the fact that because I didn't know what was causing the health complaints in homes with urea formaldehyde foam insulation, the idea was that it was formaldehyde, but the levels were too low based on what we understood at the time. We wouldn't, it's a proven human carcinogen, but we don't regulate it on its carcinogenicity. We regulate it because it's a respiratory irritant. And it took a little while to get the right number, basically. I set about in all the big housing and health studies that I've co-managed, which the very detailed ones, well, the large ones are about 25,000 people. And the very detailed ones where no expense is spared to understand what's in the house or the building, it's around 2,500, including ongoing. And the other thing that I was worried about is that I'm not interested to throw a grenade in a barrel. So I always made sure that there's engineers along the journey of the health studies so that we can get to the end and say, oh my God, there's a terrible problem, but at least try to come up with some advice about what to do. So that's been the theme. So that has given us very detailed information on houses. So the theme for me, I think, always was houses have mold problems. If it's a little bit, who cares? If it's a whole wall, what's the question? And if it's 1% or so of visible floor area, then you have a population health risk. Doesn't mean everybody's going to get sick, but there's a risk. So you should do something about it. But they also house dust mites. So prior to 1969 and 1970, respectively, house dust mites were discovered for the first time in the United States and Canada, and were rare. And now it causes, frankly, most of the asthma. There wouldn't be hardly any houses in much of the United States and Canada that, except in the very cold places, that didn't have house dust mite allergens in them. So that's part of the story. Endotoxin has been known for decades and decades to be really dangerous. And the reason for the proper test, the Limulus amoebocyte lysate test, is because you don't want it in your COVID vaccine because you'll die, not tomorrow, right then. And so all pharmaceuticals have had to be screened. So people have known a lot about that. People knew that in some occupational environments, and I'm talking about in the 70s and 80s, and we know a lot more now. And then by the middle of the 90s, it was known in houses that if there were house dust mite allergens and there was more endotoxin in the house, you would be more likely to become allergic. In other words, the more endotoxin could lower the amount of allergen present, and you'd still get allergy, which is not a fun thing, and it has to be treated, especially a very common allergen.
But that raises the question, though, David. So, I mean, why is it more prevalent? The house dust mites and the fungal issues indoors probably go back to moisture relation, right? So the way we're changing our design, our buildings are tighter.
Yeah, because we've warmed up our houses in my life from an average about 18 to about 22.
And the endotoxins related to gram-negative bacteria, same deal?
That's correct. So the endotoxins in houses, so there's three axes. There's ventilation, there's the moisture, of course, but there's also carpets. So carpets in North America were hardly known. I mean, wall-to-wall carpets until the 70s. So I have references on it. And so carpets tend to accumulate fine particles. So compared to the house that I grew up, my parents' last house was built in 1963. It had 100% oak floors. And maybe there were a few area rugs around, and the tradition in the New World in the colonial times was the housewives would take the carpet outside, beat the crap out of it, and put it back, right? Probably all of us know that. When so then it gets down to the evolution that most in this community would know of domestic vacuum cleaners having HEPA filters, which was driven by partially lead, but also the rise of the allergens and endotoxin from the perspective of the EPA or Health Canada or the physicians. And but you really need to work at it. So I was interested to know. So we know in a population level that if you HEPA vacuum the crap out of your house, that you get fewer asthma emissions. Really good studies done in Seattle by the public health department there 20 years ago demonstrated that. It makes perfect sense. If that's where the allergens are, if that's where the dusts are. It turns out that there's a mold that a lot of people are allergic to that only grows in house dust because there's skin and there's all kinds of other stuff there, right? So I was interested to know, well, let's do another study of what they did in Seattle. So I said, okay, well, let's get professional cleaners and an engineer with a stopwatch to go and clean really carefully people's homes. So I asked, we sought volunteers. It wasn't difficult to find volunteers to have their houses professionally cleaned for 2 months for free. And you would imagine the cleaners, they were totally into this because that's what they do, right? So they meticulously, and then we collected all the material and analyzed them. And it turned out that it took between around 6 meticulous cleanings by professional cleaners with the best commercial, meaning residential vacuum cleaner you could buy, to lower the dust to as low as could be reasonably achieved. So it's a lot of work, and yet the fungus that grows in dust, as many people are allergic to it as to Stachybotrys. So the perfect storm was raising the temperature, raising the humidity, raising the food, because every one of us sheds a teaspoonful of skin scales every 3 weeks. That's what house dust mites live on.
And those ugly orange shag rugs from the late 70s and early 70s, late 60s in my childhood, obviously.
Well, I can't comment on that. No, but that's where, it's because we changed. So then the question for me was, okay, endotoxin is bad, dust mites are bad, mold is bad. is the mold signal affected by the presence of dust mites and endotoxin? And the answer is no. So it turns out that regardless of these other co-contaminants, there's still the clear health signal. So it was deconfounded by some of the work. So when we go into homes now, I'm working a lot in Indigenous First Nations homes in Canada now, with a big team of people, of course, is, we want to measure everything so we can properly understand, get around our biases about what the problems might be. So when I say, to go back to the question, of what I think has changed, I think that especially some of these findings that I've talked about that have emerged in the 2010s, I would say, so that they're clear, so that physicians accept them, at least the allergy community does. The emergence of COVID again, because let's remember the earliest studies of air, CO2, and microorganisms and health in 1880 and published in 1886 and from Scottish studies, they were done because of diseases we would regard as viral diseases today. And unsurprisingly, using the most perfect chemistry method, but required a horse and buggy to carry it to the houses, was measuring carbon dioxide. It's every bit as good as we can do today, except with a little machine. Unsurprisingly, more crowded houses with lower ventilation had more infectious disease. And some of the diseases we know now are waterborne disease, so they couldn't relate them to CO2. And that's what drove the studies done by the New York School Board, by the Chicago School Board, by the Toronto School Board in the 1890s to the Depression to really understand about ventilation, infectious disease, and health. And we forget about that, because I have a picture I sometimes use of a paper where it shows a classroom in 1959, I'd like to say, with UV lamps in the freaking classroom shining up on the ceiling as a strategy to control virus, certainly for me and Don, in a population that was just barely being immunized for polio, let alone all the other diseases we got as children. So with the COVID, it seemed to me, at least it's tried to put back up on the public debate, at least in the professional communities, about the need to consider that there are always multiple contaminants in buildings. The evidence is clear how they interact or don't interact. And we have to go back, like those who tried to struggle with the high rates of infectious disease in schools in the 1950s through to the mid 70s, really, about understanding how we have to think about airborne infectious disease, particularly viral diseases, as we integrate and design our buildings and learn to properly manage them. That's what I meant.
Yeah, you brought up COVID. Of course, it's been a great interest in terms of what's going on in the changing workplace in particular. There seems to be a shift from agriculture exposures to exposures in other types of facilities, such as cannabis manufacturing facilities, compost plants, and forestry. Can you tell us what we can expect from these changing workplaces and bioaerosols?
Yeah, well, I mentioned that it was actually from the actually even back to Roman times, it was understood that if you worked in facilities where they stored grain, and the Romans and actually the Peruvians and the Egyptians had better grain stores than we did in the United States and Canada until the 70s, actually the 80s. So they knew how to do it. But it was known that you could get sick. And, those who practice in the grain business know that, there's silica, there's all kinds of other things in grain that are harmful. And there's mycotoxins. And people really got to the bottom of that for a bunch of reasons. But since that time, in the time that I've been working, and I did work on whether dioxinovalenol, the common grain toxin in the more northern areas of North America, meaning from southern Ontario to Illinois, maybe the Dakotas, certainly. Um, uh, that I worked on that in grain elevators to understand the risks there, to see if we needed to do anything more, just like the folks did in the 70s and 80s about aflatoxin in facilities that handled grain or nuts that are contaminated. So we basically addressed the concerns in the agricultural environment, I would say, not necessarily at the farmer level, but certainly for former agriculture, like Archer Daniel Midlands or Cargill, the big guys and the big millers. But then in the meantime, we've created some new environments, and one of them is cannabis. And mold is a feature of, if you don't dry dope properly, it's just like anything else. And unfortunately, it grows the facultative pathogen, pathogenic fungus, Aspergillus flavus, or fumigatus rather, is quite common. It's an allergen. It causes a disease called allergic bronchial pulmonary aspergillosis, and there had been OSHA citations for a facility that handled wood chips of the workers getting this disease, normal healthy workers exposed to very high levels of Aspergillus fumigatus. And in fact, the last project I did with the late Ken Dillon was around the fungi and wood chips. But it turns out that moving wood around and buying it from South America, that's a lot less desirable to us in North America now. So that has increased the production in warm areas in the United States a lot. So that's an area where no one would have thought about this, because it was never a problem, hardly, in northern producing areas in Canada and the northern part of the U.S. that are forestry, and not in the Pacific Northwest. But it is a problem where it's warm. So that's a workplace that people will have to be thinking about. Certainly the dope. And then if you think about composting, it's increased enormously. There's almost no, certainly not in most big cities, that doesn't make some effort to divert its food waste away from landfill, simply because it's so hard to get permission to build a new landfill, if only that. But to create composting facilities. Europe did that before we did, because we got lots of land and we didn't care. We do care now to triage that compostable waste out of our landfill. And that has created exposures in Europe, in warm areas, all the way from the workers to the people who work in the compost plants. So my reading is that there is an understanding of that, for example, in the compost sector, but not as full an understanding, because it takes folks with CIHs and other qualifications to really be that interpreter of what's going on and making measurements as they're necessary.
Yeah, we're running down on time, so I'm going to go with the one question that I wanted to follow up with you on, and see where we're going. In your CV, you note two broad areas for your research: the study of human antigens that can lead to a quantitative measurement of fungi in the air, including personal exposure, and two, determining the store-bought toxins of building-associated fungi and the effects of such toxins on lung biology.
Right.
Can you provide our audience a current status of achieving those goals?
Well, certainly we know that we can measure the allergen, but as for being able to do it in buildings, that's a bridge too far for a bunch of reasons. It turns out it could be done, but I think also that we've come to better understand, well, what could we use as proxies for that? And in the new Green Book, for example, there's discussion of measuring beta-1,3-D-glucan. And in population studies, meaning large housing and health studies or occupational studies, we measure fungal glucan. And I mentioned, I think in my talk at a virtual AIHCE, that about the Green Book, that I foresee that more measurements of beta glucan will be done as a part of the tool to rapidly assess buildings. So I think that we have developed, if you like, better proxies for that. The impact on lung biology, I would say we have more than an adequate understanding of. But it took a long time. And let me be clear that I'm not depending on, dubious in vitro tests that no one knows what it means. I walked the journey from mice to detailed, studies of allergy genes, the genes that govern allergy and lung biology, with exposures that could occur in buildings, not ridiculous ones, so that we understood which genes are being pushed, which pathways are being pushed. And that connected us back to the epidemiology. That makes sense. And it was part of the process, frankly, that allowed, I think, physicians to be more accepting that mold was a problem in buildings. And then, in other words, from real relevant animal models to probing the genetics, to exploring the differences between different toxins. And just to return to Stachybotrys briefly, it turns out that the trichothecenes from Stachybotrys are not much of a bother because they basically kill the cell. Whereas the other toxins that Stachybotrys make, and some of the others, they're more bothersome because they screw with the biochemistry. But fortunately, as I alluded to with the allergen signal, Stachybotrys requires pretty wet conditions and circumstances that are not the norm. And so I think that we understand that properly. And I sometimes allude to the work product of the American Academy of Allergy, Asthma, and Immunology clinical practice parameter committee that was chaired by Dr. Jay Portnoy for a long time. And where we produce clinical practice parameters on furry pets, rodents, cockroaches, and dust mites, which is really worth reading. And then we produce material on fungi. So in that suite, there's 3 papers that are worth this community thinking about. One of them is about, the mechanistic issues, like what do we know about that? And it's a pretty solid paper. The second one is a really nice paper written by Dr. Ginger Chu at the CDC, lead authors, and myself, and others, of course, on questions that we would wish a physician to ask about an allergic patient about the state of their house, that are framed according to where you live in the different climates in the United States and Canada. Very worthwhile, I think. And then the last paper is, there's a paper where, which is oriented really, frankly, to industrial hygienists, that's oriented towards what kind of information does a physician want to hear about from a house inspection. And that's laid out by this group of very hardworking physicians and some others, including me.
Yeah, that would be great to get the links for those, and we could include them with the
Sure.
show posting on the community. So I guess, David, just as a quick follow-up, I guess I know we're running out of time. Do you see the testing for beta glucan becoming more commonplace,
Yeah.
from indoor environmental consultants?
I
Because
do.
currently it really isn't. It
No,
isn't now.
It isn't.
Nor is
but-
mycotoxin testing for the most part.
and
People
that's
are doing spore
thank
traps.
God.
I mean,
But but I don't know who could do it reliably. And let's be clear that it says that in the Green Book. It says that in the Quad AI material. It says that in the Cognizant Authority document from Europe. It's not a personal opinion of
Sure.
mine, although it is my opinion. But the tests for glucan are done on a large scale for research studies by NCI, by NIHS, by us in the Health Canada system where we study housing and health, some academic researchers. There was a lot, and so I do think, much like endotoxin, it's basically done the same way that endotoxin is. And so it's a matter of collecting a representative dust sample, but you can measure it in air as well. I have, and compared it to area visible mold, and validated it as actually a true exposure measure, both in agriculture and in buildings, with really expensive, very large quality studies. So it relates pretty well to area visible mold in 400 homes. It's, ergosterol, which is the membrane sterol of fungi, does a little bit better. But part of the reason for that is there's a lot of yeasts often in house dust which have glucan in them. But yes, I do see that. And that is a little bit more was added in the Green Book. And in the long pending AC Judge Barrisar's book, there's a very detailed discussion that is still, I believe, transparent, that's accessible to professionals in the industrial hygiene community, on that unpacks everything I've just said about glucan. It's not complicated. We have a receptor. Turning it on is bad. It turns out that mold turns it on, which does a bunch of bad things, including to your brain. So,
well, thank you very much, David, for spending an hour with us. We could probably have spent 2,
well,
but we
I hope
we appreciate it.
Moderately useful, at least.
Oh, absolutely. I think there was a lot to unpack for many people listening in, so I really appreciate it. I also want to thank AIHA for sponsoring this broadcast. And back to you, Bob.
So again, I'll remind you all that this broadcast is a collaboration between ISIAC, the International Society of Indoor Air Quality and Climate, and the Indoor Environmental Quality Global Alliance, and of course, Healthy Indoors Media and Healthy Indoors Magazine, who we are the production company for it. So we'll be back again next month. This is a great one, by the way. I have to watch this again right now. I mean, honestly, I don't normally go back and watch the show immediately after, but there were some great points in there that I think we're going to be highlighting in the magazine as well. So we'll be back next month. Not necessarily the same bat time or channel, but same channel, but we'll be back with another edition of the Indoor Environment Show. For Don Weeks and myself, thank you so very much for joining us again, and we will see you soon.